Welcome to the first lecture on object-oriented programming. This lecture will cover the chapters 1.1 and 1.2 in the text, and let's get started. Object-oriented programming is a way of thinking about programming problems and breaking down the problem into basically abstract data types. So what is an abstract data type? It is a description of something where you describe the operations or the things you can do to this object and the state inside the object. Now, for example, here we have a water bottle. We have four things we can do to the water bottle. We can drink from the water bottle, we can fill it, we can open the cap, and we can close the cap. Now, in order to make this useful, the water bottle must maintain some information about the status of the cap and the water or liquid that's in the water bottle, but we as users of this water bottle don't need to know exactly how the water bottle keeps track of its state. So that is called encapsulation. We just know that we can do four things to this water bottle and the parameters of the method and the return values of the methods to interact with the water bottle. We don't know exactly how it is implemented, and this is a very powerful tool in object-oriented programming. So how does Java allow us to hide things or show things inside of a class? Well, they have the access levels. The most free access level or unrestricted access level is public. The things that are public are accessible by everyone. Every object, everything in a package, the subclasses, etc. If it's protected, the items and the methods are only accessible by the class itself, classes in the same package as this one, and subclasses of this class that has a protected method or member variable. If you do not have any access level next to your variable or method, then it's only accessible by the class and things in the same package, but not subclasses of this class. And private is the most restrictive. If a member variable is private or method is private, then only this class may access that member variable or method. So if you have a private member variable, subclasses cannot access it. Neither if it doesn't have any accessibility. You have to think about that when you build a class that has subclasses. And a way to define a Java abstract data type is through Java interfaces. Java interfaces are contracts between the programmers. This Java interface for a bottle is an interface because it uses the keyword interface. It defines a bottle and it defines the methods that all bottles must implement. But it does not tell you how it is implemented. It just says a bottle has a fill method that returns void that would fill the bottle. We don't know how. Whoever implements the bottle will fill in all the detail. We have a method drink that returns liquid. How it returns the liquid, how much it returns, that's up to the implementer of the interface. Open cap, close cap, the relationships between trying to drink when the cap is closed, that is up to the implementer also. So how do we implement the interface? Well, we need to define a class, glass bottle, that uses the keyword implements and then the interface name. Now, when a class implements an interface, it must define all the methods in that interface. So glass bottle must define a fill method, a drink method, an open cap method, and a close cap method. Water bottle must also implement all these methods, but they don't have to implement them the same way. They could implement them however the implementer wants. Secondly, you cannot instantiate a new interface. So to say I have a bottle Pepsi and a new bottle, that is illegal because the interface does not have enough information to be instantiated. It is just the contract. You have to implement or instantiate objects, or excuse me, classes Now, the type of the variable can still be the interface, so it's still a bottle Pepsi whose water bottle, but if it is this, if the variable is of the type interface, you only get to call the 4 methods fill, drink, open, and close cap on it. You cannot call toString on bottle because it is the variable is an interface, and you can only use the methods defined in the interface. Now, if we said that it was a water bottle Pepsi, new water bottle, then you can call all the methods that are defined and the ones that are inherited from object. Similarly, we can have a bottle champagne that is a new glass bottle because glass bottle implements bottle. But we cannot break this champagne bottle. Now, Java objects are similar to abstract data types we were talking about. You have the methods around the outside that are somewhat protecting or encapsulating the state and the variables. Often it is very good practice to use the private access level for your state variables and have the interaction with your object to be through its methods. So how do you define a class or a class? Here's an example. I want to create a class that represents a checkerboard square. So I say public class ChessSquare, and I have a private integer that shows which rank it is in, and a private string which is the file that is in. I could have used a character also instead of a string, but that's my implementation. These are private. I get to choose the implementation. How do we construct these objects? Well, there's a constructor is a method in the class that has the same name as the class and has no return value. So, for example, the default constructor is public ChessSquare. It has no parameters. You do need to instantiate the member variables such that when this constructor is finished, the class instance, that object, is a valid and correct ChessSquare. You can create other constructors with different parameters. For example, in this case, you might want to say integer rank and string file. You use the this keyword to refer to this instance. So I'm saying this rank equals the parameter rank. This is talking about, last time we talked about the scope of the variables. So this rank refers to the member variable, and rank refers to the parameter being passed in. Now, if I do not declare any constructors, Java will automatically give me the default constructor, but it will not initialize any of the member variables. If I declare a constructor that has parameters, then Java does not automatically give me a default constructor, and I must create one. So now, since the member variables are private, how does the outside world get access to information about my ChessSquare? Well, we provide accessor methods. And in Java, the tradition is to use the word get and then the name of the member variable you're talking about. So, for example, get rank, return this dot rank. Same thing with set rank. If you want to be able to set the rank of your square, you say set rank, the parameter, and then you assign that to this. Now, as the designer of the class, you get to decide whether or not all member variables could be get and set. Maybe some are private, so you can't even get them because they're purely internal data structures that you need to hold on to, but the outside world doesn't need to know anything about. You also get to decide whether or not the outside world can change your member variables. It's all up to the designer of the class. Next kind of behavior, next kind of method is a behavior. So, for example, this looks like an accessor because you're getting the color, but I'm not actually storing the color. So it is providing some behavior to the class, and being able to figure out what color the square is in this particular way is kind of tricky because I have to figure out, is it the A, the file, B, C, D, E? So I have to decide whether I'm in the odd row or even row using the mod operator we talked about last time. And then we have to do the switch on this. So this is not such an easy implementation to find out what the color is. So what if I decide to change my implementation of this chess square? For example, what if I change them to be int, the row to be an int, and the column to be an int? Now that doesn't change the outside representation. So we still want to have the integer rank in the string file. So now the default constructor is 1 and 1. We now have to figure out what the right integer value for A is, the character, the string A. So I take that, I subtract it from A, which would give me 0 if it's an A, add 1 because I want this to be 1 based, not 0 based. More complicated work on my part for the implementation, but it's my choice on how to implement it. So now what does get file mean? We have to take our column, convert it into a char, because it's going to be a 1, add the A, subtract the 1, and that will return an A for 1 or B for 2. Same thing with the set. If we want to have the set, we have to convert that back into an integer. An int, excuse me, int. A lot more work on my part, but it does make returning the color of the square much easier. It's a trade-off. The outside world doesn't know that I've had to work harder in this or easier in this. It's entirely up to the implementer. Now there are 3 special methods on Java objects that whenever you make a class, you should always override. We'll talk about overriding versus overloading tomorrow, or excuse me, next week. But we'll talk about toString method returns a string representation. It is defined in object, but it just, in the object one, just returns the name of the class, an @ sign, and the hash code. Not very useful for knowing what your object is. Hash code returns an integer, or an int, that is a hash value used for storing it into hash tables. There are some rules about hash code. The object one, I believe, just returns you the reference as an int. It doesn't really consider the contents of the object. Same thing with equals. The object equals method returns true if it's the same instance and returns false if they're separate instances. So if you had a chess square that's rank and file was, well, the rank was 1, the file was A, and a new object, another second chess square whose rank was 1 and whose file was A, if you use the object equals, it will return false, and we really want it to return true. So you should override these methods. Thank you for paying attention.